Hi, good morning, Form 5 student. Today we continue to talking about 6.3, the practical 3D problem. So beside yesterday, we have learned how to solve the trigonometry 3D problem by using the angle of elevation and angle of depression. Today, we will focusing on another one, okay? So today what we need to do is we need to learn how to apply the trigonometry knowledge in solving the 3D problems such as paper folding question. So this is super important, okay? Make sure that you watch the video for several times. So why this is super important? Because look at here. So you can see that I write it down all the question in DSE, okay? So you can see that the first year of the DSE is 2012, right? So starting from 2012, every year we have the paper folding 3D problem in DSE paper, okay? Normally they will be in between question 17, 18, and 19. So all of them are section B question, okay? So I hope that you know what is section B question. Later on, we'll have one more video to describe the DSE paper to you, okay? So now, look at this. The mark carried on this question, the 3D problem about the paper folding, around 7 to 13 mark. So this is very important topic because every year they will test you. So we can assume that when you to take the DSE exam, probably you will facing one of the 3D paper folding question. So you need to know how to solve it, okay? So this one, we need to use the information that you have learned in chapter 5 about the cosine formula, okay, and sine formula. I hope that you still remember how can we use it. So cosine formula will be using 3 sines plus 1 angle. Then sine formula is 2 sines and 2 angles. Okay, so their formula is look like that. So a squared will equal to the adjacent side b squared plus c squared minus 2bc cosine theta. Theta is the adjacent side, okay? So bc theta, then a, okay? Then next one, sine formula. Sine formula is 2 sine and 2 angle. It will be sine angle a divided by a equal to sine angle b divided by b, okay? The triangle will look like that. We will have the a opposite is the a side, b angle opposite is the b side, okay? We're using those two information, okay, to find all the answer, okay, to solve the triangle. Now let's try to do the quick practice 6.13 and 6.14 to learn what is the paper folding question. Okay, this is super important in DSE, so we must know how to solve it. Okay, so let's start. So now, quick practice 6.13, let's take a look at this question. Okay, you can see that we have two figures, figure A and B. Let's read the question together. Figure A show a rectangular cardboard ABCD with the AB length 10 cm and AD equal to 12 cm. P and Q are the midpoint. Okay, midpoint means that we divide into half. So each one will be 5 cm. Okay, got it? Then the cardboard is then folded along PQ to put on a horizontal table as shown in the figure B, such that the angle APB equal to 50 degrees. So if you are not good at 3D shape, okay, the geometry shapes, please use a piece of the paper to fold it by yourself, and then you will have more clear idea what is the paper folding problem. Okay, now I will show you a video, okay, how can I fold it, and then you can try to do it by yourself. So you can see that I fold this, okay, draw it out A, B, C, D, and then PQ midpoint, then fold it. Okay, after you folding, you can see that the paper should look like that, okay, with the angle standing on the ground. Can you see that? You can do it by yourself. Then we come back to the question, okay? So this is what you need to do, okay, if you're not good at 3D shape. So now let's try to solve the problem, okay? So referring to the figure B, I want to find the distance between A and B. Remember, we have two A and B distance. This one A and B, see? This one also A and B. So we are talking about referring to the figure B. So that means not 10 cm? Of course, no, right? If you just write down 10 cm, why we need to do the calculation, okay? So I want to find this one, AB. Now the problem is, I want to find this one, I need to think about cosine formula or sine formula, okay? But which one will be suitable for us? Let's try to draw the triangle out first. So I'll have the P, 50 degree here on the ground, A and B, okay? So you can see that I want to find the AB. I only got one side, one angle. So how can I solve it? So I would suggest you using cosine formula. Why? Because cosine formula is 3 sides plus one angle. Okay, one angle you already got it. Now the problem is try to find out 3 sides. So that means you need to find out the PB and PA. Okay, so is it difficult to find the PA and PB? Of course no. Okay, so you can see that it's the paper folding. PA and PB is 5. Okay, can you see that? Even though they are forward, but the distance, the length won't be changed, right? So it still be 5. So super easy. Okay, so you just mark it down. Yeah, this is 5, 5, and then I want to find the AB. So using cosine formula, 3 sides, 1 angle. Okay, so it will be AB squared equal to 5 squared plus 5 squared minus 2 times both sides, then cosine 50 degree. Okay, then using the calculator, you can find out the AB. Okay, make sure that give me 4 decimal place first, then you give me 3 significant figure. Why I need to keep the prefix 1? Because I want to reduce the error if I need to use it in question B. Okay, so now let's start question B. Question B say that please find the angle AQB. So let's look at this. Okay, figure B. Where is our AQB? So try to highlight it. AQ, AB. Okay, so we have the angle AQB here. So what you need to do is sketch out. Okay, again. So we got the Q, we got the A, we got the B. Then don't forget, you have to find AB in A part. So in math question, normally we will like to using the prefix answer. So we have the AB 4.2262, 4 decimal to reduce the error. So that means I don't know QA and QB. Okay, I need to find out. Again, can you see that? 3 sides, 1 angle. Okay, 1 side, 2 side, 3 side, and 1 angle. So cosine formula again. But before we using cosine formula, I need to find out the QA first. Okay, so how can we find out the QA? QA actually is this one. Can you see that? So this is right angle the triangle again. So how can we find the QA? Using Pythagoras theorem. Okay, so QA will equal to 12 square plus the 5 square. Okay, square root. So QA will equal to 13. Now, yes, we find the QA, then actually QA and QB are the same because they are at the midpoint. Of course, these two are the same. Okay, so we can write it down. This is 13, 13. Again, 3 sides, 1 angle, cosine formula. Okay, so let's start. Cosine angles AQB will equal to 13 square plus 13 square minus 4.2262 square divided by 2 times 13, 13. So we got the AQB. Okay, again, one more time. Don't just give me 3 significant. Okay, 4 decimal first, because maybe we need to use this answer in question C. Okay, so final answer, 3 significant figure. Got it? So this is B part. Now we go to the last question. Okay, last question is I want to find the angle between the plane QAB. Okay, I draw it out already, and the horizontal table. So horizontal table is this one. Okay, so if you think that you are quite difficult to find out the angle, let's repeat one more time what we have learned in session 6.1. If I want to find the angle between them, we need to start with the vertex. Draw a perpendicular line. Okay, when you touch the horizontal plane, okay, extend again. It's also perpendicular. touch the vertex. Remember, if you got a triangular plane, it's always start with the vertex and then linking. Okay, so we need to find this one. Got it? Okay, so now let's try to do it. So we have a purple triangle here. I want to find this angle. So how can we do it? Try to sketch the purple triangle out. Okay, maybe it helps us to be more clear what we need to find. Okay, so I have the Q, P, and then this one. Okay, I need to let this one be M, maybe the middle point. Okay, so I want to find the angle between them, this one. So again, one more time, if you got a three side, one angle, of course, cosine formula. But this time we got a right angle. Can you see that? Right angle triangle, that's me. Yeah, we don't need to use cosine or sine formula. We can just directly using trigonometry ratio, sine, cosine, tangent. Okay, so QB, we already know the length. QP is here. Can you see that? QP. So actually it's 12. So we mark it down. This is 12 cm. Okay, then we need to find one of the length. Maybe QM, maybe PM. Okay, just try to find out one of them and then you already can solve it. So this time maybe I try to find PM. Okay, so it's up to you to choose which side. So I try to find the PM. So how can we find the PM? Again, PM is a triangle on the ground. Can you see that? So I draw it up. I have the PAB, then perpendicular bisector at M. Okay, so what we need to do is, I know that this is 5 cm, PA and PB, right? Then AB, we already find it. Okay, AB already find it in section A. Okay, so you can see that here, just half of it. So what we need to do is half of it, then it will be 4.2262 divided by 2. Okay, so we just pick up one of the triangle, half of the triangle to calculate. So how can we find the PM? PM will equal to 5 square minus 4.2262 divided by 2 square. Then square root, Pythagoras theorem. Okay, so 4 decimal place again, 4.5315. So yes, we got the PM now. So PM is 4.5315. So I want to find the angle. Of course, you can using tangent. So tangent's angle QMP will equal to 12 divided by 4.5313. Okay, then using arctangent, you find the angle. So because this is the last one, so we don't need to keep the 4 decimal, because the section C question won't use as section D because you don't have the D, right? So this is your final answer. But don't forget, you need to answer the question, because the question is asking you the angle between the plane, So please answer the question. So you need to say that the angle between two planes is 69.3 degrees. Done. Okay, so this is paper floating question. So you can see that we need to use sine, cosine, tangent. We need to use Pythagoras theorem. We need to use sine law, cosine law. Okay.